this is a demonstration of how we're going to use the input section of our lesson. Our lesson is specifically taking the grid multiplication method from an inactive or iconic representation mode through to being a symbolic mode. So the formal method set out in a grid similar to the one you see there. I'm not going to go through all the slides. I will just say that we were supposed to have some place value cards here, but I can't find the tool on here. I just have to explain that it would be there. In this sum, I've laid all these out as well at the start just to save time. We would have the place value card to show that the number 13 is made up of constituent parts 1, 10 and 3 units. After somebody's, hopefully one of the children has come up and used the smart notes tool to build a sum like this, we can start counting these. So 10, 20, 30, 40, 50, 60, count for them in the class, knowledge of the 10 times table. The 60 moves over to this regrouping area here, where we're going to use column addition to find out the answer to the sum, to the question. Okay. Slightly more difficult question there now. And we're going to show that we can use use the Dean's blocks to represent the amount of bananas when we've got a larger amount, because otherwise we just won't have enough space. Place value cards down again. This time we've got 2 lots of 10, so we've got a 20 and 3. This time, once we've counted down our Dean's blocks, we can exchange obviously for our 100 block when we need to. We can bring that down and exchange for 10, 10. The key part in the key concept of moving into this kind of formal representation is going back to the key vocab, knowing that your 20 here, we've got 6 lots of 20. 6 lots of 20 is 6 times 20. We've broken up the sum to 6 times 20 and 6 times 3. So then, offering up a grid like this, generating some numbers randomly from the class, we can partition them again using the place value cards, place the numbers in the right places in the grid. And then, rather than bringing out Dean's blocks and counting, we're just going to use 6 times, for example, 20. Using our knowledge of place value, perhaps going back to 6 times 2 and then multiplying that by 10 to show that this is a, I won't say easier, but a way of using this grid to answer more complex questions. So some of the children in the class might have to stop with this 2 by 1 digit method. Some children will still be using the inactive method, but hopefully some children will be able to partition 2 numbers and go into 2 by 2 digit questions.